Hello, this is the Philosophy of Science lecture slideshow for week 7. These slides cover the 7th week of the course, and for this set of slides, read the rest of Handout 2 in Module 3, sections 12 through 19. Explore also the links to additional content within Canvas Module 3, especially the short videos that I have on this page. Click on that page, you'll see about 5 videos. Read the Wikipedia entries on cognitive biases, and in particular, base rate neglect, availability heuristic, and confirmation bias. They will be the subjects of our lecture today. What biases undermine scientific reasoning? Let me summarize what I've said thus far. Evidence for beliefs based on personal stories or testimony under uncontrolled or poorly controlled circumstances is weaker than evidence from peer-reviewed randomized controlled trials. It is more biased, inaccurate, and unrepeatable. It is less reliable, that is, susceptible to perceptual and memory errors, and less amenable to objective testing. People are terrible at assessing probabilities. Justification in science always depends upon evidence, a standard of evidence, and a valid or strong argument. What you always have to ask when checking any justification based on science or otherwise are the following 4 questions. Am I only looking at evidence that supports a claim? Am I dismissing evidence that might show that a claim is false or dubious? Am I only looking at evidence from my own experience or that of others? Am I not looking also at any relevant statistical findings? If the answer is maybe or yes to any of these questions, then I am probably yielding to a cognitive bias that corrupts my justification for a belief or a claim. Cognition. What does that mean? This is the term we use to describe a mental action or process of acquiring knowledge and understanding through thought, experience, and the senses. Biases corrupt and mislead human cognition. In this lecture, I discuss the top 3 biases or errors that I think infect our reasoning about scientific observations and conclusions. Academics debate whether cognitive biases are errors in judgment or rational deviations from logical thought. However, it doesn't matter for those of us seeking to understand how we draw mistaken implications from observations, data, and subjective experience so that we can avoid them. Wikipedia has a nice list of cognitive biases worth reviewing, but I only focus on a few in my lectures. So what is bias? Bias is a systematic error or deviation from the truth in measurements, perceptions, or inferences, beliefs. The general problem with biased reasoning is that factors other than evidence move us away from truth. A cognitive bias is the human tendency to make systematic decisions in certain circumstances based on cognitive factors rather than evidence. Such biases are mental shortcuts we often rely upon but actually should not. When making judgments, people tend to overestimate the probabilities of unlikely events and overweight rare events in their decisions. So the general problem with biased reasoning is that factors other than evidence move us away from truth. Since our minds are so error-prone, researchers conclude either that this tendency is practical, has some kind of survival value, but unreliable as a path to truth, or that it is impractical, survival-threatening, but only sometimes reliable, truth-revealing. Either way, we are too often irrational about what we believe due to biases. Sometimes we are correct, and sometimes we aren't. This means we can't trust our judgments. There are many well-known cognitive biases. We discuss 3. Here are 3 of the most common cognitive biases: base rate neglect, availability bias, and confirmation bias. Here are 3 common cognitive biases: base rate neglect, availability bias, and confirmation bias. You should find your own real-life examples to show yourself that you actually understand these. We'll start with base rate neglect. Base rate neglect, or the base rate fallacy, is overlooking general statistical data in favor of specific data when making a probability judgment. A base rate is the prior probability of some event happening. A base rate is a statistic used to describe the percentage of a population that demonstrates some characteristic. For example, the odds of being struck by lightning in your lifetime is 1 in 12,000, and your odds of developing a brain aneurysm, a bulging or rupturing of an artery, is 1 in 50. The base rate for breast cancer in women is 1 in 8, or 12.5%. About 1 man in 9, or 11%, will be diagnosed with prostate cancer during his lifetime. The base rate for colorectal cancer is 1 in 23, 4.4% for men, and 1 in 25, 4.1% for women. Base rate is identical with prevalence, the prevalence of a specific trait in a specific population. Base rates refer to the relative frequencies with which certain states or conditions occur in a population. Epidemiologists use the term prevalence. A base rate is defined for and restricted to a specified population. It is the prior odds that a member of a specified population will have a certain characteristic, assuming that we know nothing else about this person other than that they are a member of the population we are describing. For example, the base rate of suicide in the general population is less than 1%, whereas the base rate of suicide for a more restricted population, for example, among patients with borderline personality disorder, may be as high as 10%. People are terrible at estimating risk. Nevertheless, people trust their unschooled intuitions. The risk of death from flying is often perceived as high, but in fact it's the lowest of all means of transportation per distance traveled. When Ebola virus emerged, hemorrhagic fever, people were very fearful of it here in the United States. But the base rate of deaths due to Ebola virus in the United States since 2014 is less than 1. Now the base rate of deaths due to Ebola virus in West Africa since 2014 is greater than 11,000. So, the relative risk of death due to Ebola in West Africa is at least 11,000 times greater than in the U.S. Yet, people in the U.S. fear Ebola way out of proportion to the risk or the prevalence of Ebola in the U.S. Now consider our current situation with coronavirus as compared to seasonal flu. The base rate of annual deaths due to influenza virus in the United States, on average from 2010 to present, is somewhere between 12,000 to 61,000 deaths. The base rate of deaths due to coronavirus in the U.S. thus far in 2020 is greater than 214,000. So the relative risk of death due to coronavirus in the U.S. is at least 3.5 times greater. Yet many people in the U.S. fear coronavirus no more than they do seasonal flu. And we even have vaccines for influenza, which diminish the death rates. To ask how likely are these events is to ask what the base rate is. How many people are struck by lightning that actually die? 1 in 10. So people fear lightning strikes, but only 10% of people die. That's still a high percentage. 9 in 10 people are smartphone owners. 1 in 2 people have a car accident within 5 miles of their home. The odds of being an American who is a Christian is 1 in 3. The odds of a death involving a firearm is 1 in 100. The odds of a death due to a motor vehicle accident is 1 in 100. The odds of a coin toss sequence being 5 tails in a row is 1 in 32. I'm going to give you a couple of more detailed examples of base rate neglect or the base rate fallacy. Question: does the stress of being a commercial pilot cause cardiovascular disease? Suppose we observe that 30% of pilots have cardiovascular disease. That sounds like a lot. Can we conclude that commercial piloting is a risk factor for cardiovascular disease? No. You need first to compare the frequency or the base rate of cardiovascular disease in pilots to the frequency of cardiovascular disease in the general population. The general population base rate prevalence of cardiovascular disease is approximately 40%. So in our example, the risk of cardiovascular disease in pilots is 30%, and that's less than the 40% base rate in the commercial population. Now, we can't jump to any conclusions about that. But you see how we would make a mistake if we were to think that the 30% base rate of cardiovascular disease in pilots was somehow caused by the stress of their being pilots, when in fact they appear to have a lower base rate. Prevalence is the proportion of cases in the population at a given time. Here is a list of what kills Americans, the leading causes of death. You'll see diseases of the heart far exceed as a cause of death, for example, influenza and pneumonia. If the base rate of cardiovascular disease in the population is approximately 40%, then 30% cardiovascular disease is not higher. And even if it were higher in pilots, we would need peer-reviewed randomized controlled trials to test whether stress causes cardiovascular disease. When you fail to take into account relevant background frequencies or prior probabilities of events and judge based on specific cases, then you neglect base rates. People say studies show that a small but noticeable percentage of people are cured of incurable diseases such as cancer. Faith healing, prayer for a miracle works, but not all the time, especially when one's faith or financial offering is not strong enough. But even cancer remission happens. The number of people who attribute their cure to faith healing is lower than the number of people who get better spontaneously. Available scientific evidence does not support claims that faith healing can cure cancer or any other disease. So what is the base rate of cancer remission? Let me define remission in the clinical sense. Remission is a decrease in or disappearance of signs and symptoms of cancer. In partial remission, some, but not all signs and symptoms of cancer have disappeared. In complete remission, all signs and symptoms of cancer have disappeared, although cancer still may be in the body. So remission doesn't mean the cancer is gone. In one study, spontaneous remission of more than 1 in 5 invasive cancers detected by mammography occurred without ever being treated. 1 in 5. That's 20% of breast cancers diagnosed by mammography stops, doesn't progress. Speculation. The natural course of some screen-detected breast cancers is to spontaneously regress. There is much confusion about base rate neglect. Sometimes we overlook base rates, and sometimes we are operating with the wrong base rate. Both are cases of neglect. Both are examples of the base rate fallacy. In the case of the pilots, we see 30% cardiovascular disease rate and jump to the conclusion that the stress of being a pilot is a factor, but we are overlooking the 40% cardiovascular disease base rate in the general population. We make a similar mistake when we judge with the wrong base rate. For example, we know that heart disease is the leading cause of death in the U.S., but that risk is not the same for a randomly drawn person. Black women have a base rate of 49%. Black men have a base rate of 44%. They have higher rates of heart disease than white men, 37%, and white women, 32%. When you fail to take into account relevant background frequencies or prior probabilities of events and judge more on stories, specific cases than statistics, then you neglect base rates. Let's talk about availability bias. This is over or underestimating probabilities of events associated with memorable stories or vivid experiences. The ease with which examples come to mind can make us overrepresent their relevance, and we judge poorly based on those. Emotional or personal experiences, vivid examples, scary pictures, sensational media are more available to us than are statistics about event frequencies. But they are not more relevant just because we can easily cite them or recall them. When you base your judgment on outstanding, eye-catching factors more than actual measured frequencies, then each factor is a potential source of bias. For instance, because of the coincidence of 2 planes crashing last month, she now prefers to take the train. Of course, school shootings are on the rise this year. All you have to do is notice that every week and sometimes more than once a day, a mass shooting incident at a school happens. Another example, I don't feel the need to get a flu shot because none of the people I know got the flu last year. Or somebody says global climate change, global warming is not real. Winter this year was just as cold as last year and the year before. Here you're mistaking your own experience for adequate data, good data, you need to justify believing global warming is real. Availability bias is called a heuristic. A heuristic is a procedure for deciding. A bias is a tendency to decide poorly based on less relevant factors. Each affects the other. Heuristics of judgment substitute one question for another. Heuristics are mental shortcuts. You want to estimate the size of a category or the frequency of an event, but you report an impression of biasing factors other than statistical frequency. Availability bias, availability heuristic, same thing. This is judging the frequency of an event by the ease with which instances come to mind. For example, personal experiences, pictures, and vivid examples are more available to us than incidents that happen to others or actual statistics. Jack's child develops autism after an MMR vaccine, so Jack doesn't trust vaccines. Availability bias is a substitution heuristic that underlies cognitive biases and perceptual illusions. A heuristic is a problem-solving strategy or an information processing shortcut. Often, almost reflexively, when we get a complex question, we just substitute a simple one for it. And then we supply the easy answer to the simple question, as if it's a good answer to the more complex one. For example, how frequently does this happen? Becomes the question, how easily do instances of this come to mind? We substitute the latter question for the former. How happy are you with your life these days? Someone asks. Becomes, what is your mood right now? Substitution heuristics cause reasoning errors and biases. Our estimates of the chances of specific outcomes get skewed by perceptions and biases, so we draw erroneous inferences and distorted judgments. The question, what are the best careers for making a lot of money? Becomes, what careers do I know where people make a lot of money? That's a different question. What fraction of chores have I done? Becomes, how many chores do I remember doing as compared to the amount of chores I remember my partner doing? The question, how likely am I to become infected with COVID-19? Becomes, how many people do I know that have COVID-19? Very different questions. Coronavirus cases are skewing younger, but older Californians make up a vast majority of deaths. In our personal experience, it certainly doesn't seem like people from the ages of 18 to 34 are the most likely to be positive for coronavirus. And yet, that's the fact. That's the base rate. But I don't know anybody who died or even got sick from coronavirus, people say. Young adults are infected more frequently than children or older adults, who make up a smaller portion of the population. But an astounding 8 out of 10 coronavirus deaths have been among adults 65 and older. This is what happens when we take readily available but flawed personal experiences too seriously. We don't realize how many people are infected with coronavirus or which groups are most likely to be infected. We don't realize how likely a person in a specific age group is vulnerable to death due to coronavirus infection complications because of our limited available experiences and our lack of diligence in looking for objective empirical measurements of infection and death rates. And so we judge poorly our relative risk of infection, being infectious, risk of death. Media emotions fuel availability bias. Strokes cause almost 2 times as many deaths as all accidents combined. But respondents judged accidental deaths to be more likely, where a non-accidental death is an illness or a natural event. Tornadoes were seen by people as more frequent killers than asthma, although asthma causes 20 times more deaths than tornadoes. Death by lightning is judged less likely than death from botulism, food poisoning, even though it's 52 times more frequent. Death by disease is 18 times as likely as accidental death, but the two were judged equally likely. Death by accidents is judged to be more than 300 times more likely than death by diabetes. Here is the list of the number of deaths for leading causes of death in the United States. These are the base rates. So if you think about how likely you are to die of influenza or pneumonia as compared to dying from diseases of the heart, you might not think, based on experience, that death due to heart disease is 10 times as frequent as death due to influenza and pneumonia, but it is. You can control for availability bias by listing many rather than a few irrelevant instances. The greater the number of examples you can retrieve you can recall, and the lack of ease with which they come to mind, the difficulty you have recalling, will erode overconfidence in your judgment. For example, people are less impressed by a car after listing its disadvantages. People are less confident that an event was avoidable after listing more ways it could have been avoided. People are less confident in a choice or judgment when asked to produce more arguments to support it. We seek data that are likely to be compatible with beliefs we hold currently. And we dismiss data and evidence that is inconsistent with our beliefs and expectations. People who like President Obama are predominantly the same people buying books which describe him and his life in positive terms. People who dislike Obama are the ones buying books painting him in a negative light. Many buy these books for confirmation, not information. Confirmation bias is a selection bias. It's selecting non-random, non-representative samples. Here are some examples of confirmation bias. Someone asks you, is Sam friendly? Sure, all of my experiences with him have been positive. Student to teacher, how could I only get a C on this research paper about whether global climate change is real? I found and analyzed the top climate change skeptics on this. Confirmation bias is a kind of tunnel vision that distorts our observations and statistical findings. Another term for confirmation bias with which you may be familiar is cherry picking. But cherry picking evidence that favors a beloved or popular hypothesis fails to consider all relevant evidence, especially negative evidence. For this reason, philosophers of science advise testing hypotheses by deliberately trying to refute or disconfirm rather than support them. Why? The probability of an event, especially a rare event, is most likely to be overestimated when an alternative is not fully specified. This is especially the case when no alternative is considered, or when any other alternative is unpopular. Confirmation bias makes us overconfident in our judgments, when liking our hypothesis should be a red flag for checking it more. Earth is visited by extraterrestrial aliens because unidentified flying object sightings are real. But have we considered alternative explanations of unidentified flying objects? They could just be things we don't know what they are. They could be experimental aircraft. They could be military aircraft from the United States or from some other country. They could be weather events, meteorological phenomena, all of which are much more likely than that we are visited by extraterrestrials. Overconfidence in our abilities is another kind of confirmation bias. Ask anyone with a driver's license to rate their own abilities behind the wheel, and most people will report that they are above average drivers. This is true for self-assessments of performance in cognitive tasks, of attractiveness by men, not by women, and of the healthiness of our behavior. People typically place themselves higher on the ladder than they really are. In a survey of 1 million high school students, 70% rated themselves as above average leaders versus 2% who thought of themselves as below average. And a spectacular 94% of college professors possess teaching abilities that are above average, according to themselves. They can't all be right, but that doesn't make them dysfunctional or mentally unhealthy. It just makes them wrong. So how do we avoid drawing biased conclusions? Bias is always there. How do we control for it? We get justifications first before we make judgments. We could require that all beliefs be supported by logical inferences, arguments, before we accept them. We should, but this rarely happens. Models of rationality based on arguments, inferential models, say that justified beliefs and actions need to be based on formal reasoning methods. This sounds promising until we see the very high rates of error most people have when given reasoning tasks. Either people are not justified usually in their judgments, or we lower the justification evidence standards and say they are, sacrificing truth for trust. What do we do for justification in science? The short answer: accept no hypothesis, description, or explanation without a good argument, one which is logical in form and is grounded in acceptable, relevant, testable evidence. Never trust feelings, faith, personal stories, popular ideas, intuitions, or mental shortcuts. These are unreliable and poor justifications for our judgments. Controls for biases, which reduce our own subjective and systematic biases, are necessary. Without these, we simply cannot trust human judgment. We can use it, but we can't trust it. We can't trust it because it's not reliable. Up next, in the next lecture, what is the difference between science and non-science? How exactly does scientific reasoning work? I'm going to give you a short historical introduction to the logic of science. For this, next week, read handout 3. Logic, empiricism, positivism, a brief history. See also the shorter handouts in Canvas under assigned reading. That is handout 3A, 3B, 3C, 3D. Read also the Ayer, Popper, Hempel, Hume excerpts available in Canvas Module 3. This is the end of the slideshow.